Hello there, this is Randy. Today we're going to talk about some scenarios where one or more of the factors of a polynomial are raised to an exponent that is greater than 1. We call this multiplicity. Let's go. So let's start with a simple example. F of x is equal to x plus 2. And right here we can see the graph of that function. So where is the 0 on this graph? Well, the 0, or the x-intercept, or also known as the root, R-O-O-T, is right here at x equals negative 2. And we know that because we could set this factor equal to 0. We could say x plus 2 equals 0, and then minus 2, x is equal to negative 2. So we could have discovered that 0 algebraically. Now, what happens if I take this factor and I square it? So we have a new function that is x plus 2 all squared. So you can see that we still have a 0 or a root or an x-intercept right at x equals negative 2, but we have a squared factor. So one way to describe this is by saying that we have a 0 at x equals negative 2 with a multiplicity of 2. And that multiplicity of 2 comes from the exponent that the factor is being raised to, which in this case is 2. Now, what do you think will happen if we replace this 2 in the exponent with a 3? Do you think that it will cross the x-axis or stay above the x-axis? It now crosses the x-axis again because this exponent is 3. So we still have a 0 at x equals negative 2, but now this is a 0 of negative 2 with a multiplicity of 3 because of that 3 in the exponent. Now, what do you think will happen if we change this 3 right here to a 4? Now, all of a sudden, our graph does not cross the x-axis. It remains positive, that is, above the x-axis in the entire graph. So we still have a 0 or a root or an x-intercept of negative 2, but now this is a 0 of negative 2 with a multiplicity of 4. So what is the pattern that we're seeing here? When we have a factor with an odd exponent, like 1, right, because there really is an invisible 1 in the exponent on this factor. So there's that 1 right there. Or an exponent of 3, that's another example of an odd exponent. We can see that the graph crosses the x-axis. But if we have an exponent that is even, such as 2, like in this example, or an exponent like 4, there's another even example, our graph does not cross the x-axis. So an odd exponent means that the graph will cross the x-axis, and an even exponent means that it will not cross the x-axis. That is, the exponents on a factor of the polynomial. Now, let's look at an example where we have more factors and thus a much more complex graph. So right now we're looking at the graph of f of x equals x squared times x plus 2 all squared times x minus 1. Now let's make some observations about the graph. It looks like our graph touches the x-axis 3 times, once at x equals negative 2, once at 0, and once at x equals positive 1. Let's see if these zeros that we just identified correspond to the zeros that we would find algebraically. So in order to find the zeros algebraically, we're just going to take this factor and set it equal to 0, and then this factor and set it equal to 0, and this factor and then set it equal to 0. And then after all that, we'll need to remember that this 0 that we get will have a multiplicity of 2 because it's squared, and this 0 that we get will also have a multiplicity of 2. So when we set x equal to 0, we just get x equals 0. And when we set x plus 2 equal to 0, we subtract 2 from both sides and we get x equals negative 2. And when we say x minus 1 equals 0, we add 1 to both sides and we get x equals 1. Now let's look at these 3 zeros in the context of the graph. And then we'll talk about the multiplicity. So x equals 1 corresponds to that 0 right there. X equals negative 2 corresponds to this 0. And x equals 0 corresponds to that 0 right there. Now, which of these zeros have multiplicity? obviously just the first two. This x equals 0 has a multiplicity of 2 because the x was squared, and this negative 2 has a multiplicity of 2 because its factor was squared. And that totally makes sense on the graph because, as we've discussed, having an even exponent on the factor will cause the graph to touch the x-axis but not cross it, such as in this case, you can see it touches it and then goes back down. And then same as at x equals 0, it touches it and goes back down. But x equals 1 has an exponent of 1 right here, even though we don't write it. And that means that because this is odd, it should cross the x-axis at x equals 1. And we can see that right here, it does in fact cross the x-axis, going from negative to positive. So if you saw an example with this graph right here, and you were asked to match this graph to the equation, and let's say that you had 4 options. You had this equation, and then you had an equation that had, instead of x squared, you just had x. And then if you had another equation where you had x plus 2 but it wasn't squared, and then you had another equation with x plus 1 squared, you would know that all of those alternative options would not be correct because those would not give us the output of this graph. Because, for example, if we had just x instead of x squared, we know that the graph would cross the x-axis at 0, right? Because this is an x with a multiplicity of 1, so it would have to cross right there. So we know that that option would not be correct. In the same way, if we had x plus 2 but it wasn't squared, then we know that right here the graph would cross the x-axis because this right here is the same as saying an exponent of 1 if we just have x plus 2. And in the same way, if you had some option that was x minus 1 squared, we know that this graph right here would not correspond to the equation anymore, because if there is a factor that is x minus 1 squared, then at x equals 1, it would need to bounce off the x-axis, right? Because this even exponent means that the graph will bounce off the x-axis because it is an even multiplicity. So, quick review. Odd multiplicity means that the graph will cross over the x-axis, and an even multiplicity means that the graph will bounce off the x-axis. Another way to think about it is with even multiplicity, such as in this case, the sign of the polynomial does not change when it touches that 0, right? Because it's negative here and negative here, negative here and negative here. But when we have an odd multiplicity, like 1 or 3 or 5 or 7, then the sign of the polynomial changes when it touches that 0. It goes from negative to positive. Or in some cases, it could go from positive to negative. And with that, we are finished. See you next time.